Hello, my name is Rob Garner. I'm a computer programming instructor, and today I'm going to demonstrate how to create a custom module. So I'm going to start with the custom handler demo we had before. And this is the one that had a custom handler that we created that inherited from IHTTP handler and just provided a simple kind of hello world functionality. What we're going to do is we're going to create a module, and a module is basically a class, just like everything seems to be in .NET. So we're going to add a class, and we're going to call it module sample. And our module sample is going to inherit from IHTTP module. If you get red squiggles, it probably means we're missing a using statement. You can click Control Dot, and that will bring up using some proposed fixes to it. In this case, we're going to add using system web. Now red squiggles go away, and that makes this available. If we go to definition, we can see what this IHTTP module looks like. And the IHTTP module really just has two methods we have to implement: a dispose method and an init method. So an easy way when you're inheriting to implement all your methods is just right click and implement interface, and what you find is the Visual Studio will stub out those methods for you. Now what we want ours to do is to look at a file of allowed addresses. So for now what I'm going to do is create a private constant string to represent the file name for my allowed addresses. And a list of strings to hold those allowed addresses. And the reason we're doing this is just to demonstrate how you might make a custom module. This is not something you would normally frequently do, but it helps us to understand a little bit about how .NET works. So here we have this init method. We're not going to do anything with the dispose method, so I'm just going to get rid of that throw not implemented exception. And we do want to do things with the init method, and this is where you would typically add things that you want to do with your module. In this case, we can take this context object that gets passed in, and so when this module gets initialized with your application, this init method will be called, and our context, and when it gets called, .NET will pass in the context for the application. And by passing in this context object, it gives us a number of things we can access, as you can see here through the IntelliSense. One of the things, for example, let's say you wanted to do something with logging. You could, for example, click on log request, and the log request method occurs just before ASP.NET performs any logging for the current request. So maybe if you wanted to set some kind of custom logging function up, you might do this. And these are event handlers. So what you do is just like you do for any event handling, you add event handlers to it, and to create event handler, you say new event handler and pass in the target you want or the method you want. We haven't created one, but an easy way to do this is just say pass in the name for the delegate that we're going to want, and if we hit control, if we right click, we have this generate method, and which is a nice and convenient way that Visual Studio provides us to generate our method. So we could have written this all from scratch from the beginning. I find a lot of times it's easier if I need a method, just write the name and generate method stub, and it does it for me. And we're not going to do anything with this, but you could put whatever code you wanted here, and this would be executed when this module was initialized. What might be more useful for us is handling the begin request event handler. And this occurs as the first event in the HTTP pipeline of execution when ASP.NET responds to a request. So when ASP.NET responds to a request, it generates the application, and if you have this module, it'll call this begin request. And we're just going to stub out again a method. I'm just going to provide its name and generate the method stub. So now I have this begin request, and then the question is, what do we want to do? Well, we probably want to load some addresses, so I'm going to stub out a method and we know that what's going to call this is a HTTP application. So the application is going to call this method, and it will be passed in by .NET as the sender. So I'm going to take sender and cast it as a application so that I can get access to the context property and pass that in to my load addresses method. My load addresses method is going to take this context as an argument. So all of this, it will be one parameter. And again, I'm going to generate my method stub to make this other method. So you may be asking, why are we doing it? Why couldn't I just put this code directly in begin request? We could, but it's usually considered a good idea because begin request may have multiple things it does. Separating things out into individual methods is a good idea. So what this method is going to do is it's going to look at allowed addresses here and see if it's null. If it's null, it means it needs to be initialized. If it has something in it, it means that it's already been initialized. So we're going to do this check here to see if we have anything allowed addresses. And if we don't, what we want to do is reopen the file that has the allowed addresses, read them, and then set them into allowed addresses. So I'll need a path to that file. And the way we do this is we take the context object, which is coming in. I actually want this to be just named context. And we're going to take the server object from this context. So if we can get the server that this HTTP request is coming onto, and then I can use the server has a map path method, which will return the file path to the actual file that is on that server. And the reason we want to do this is depending on which server it's on, we don't have an absolute way of knowing what the address is going to be. So this map path will take the string, which in this case is the file name that we have here, and it'll just append that to whatever path is associated with the server that is our web server. So this is a way of getting access to a file and making the path. And we want this to be allowed addresses file. So we want this file name here. And we'll take that file name, and this map path method will append it to wherever our actual server has placed our application. And then what we want to do is we want to read from that file into allowed addresses. And we're going to use using system IO. So I needed to add using system IO. And the file has a read all lines. The nice thing about this, normally when we deal with files, we have to put them in a using block, or we have to make sure we open and close the files. The read all lines method actually will do everything for you. It'll open the file, it'll read all the lines, and then it'll close the file. We're going to use this path that we created that points to where our file is, and I'm going to convert it to a list because allowed address is a list of strings, and read all lines, you can see here, actually returns a string array. So I don't want an array, I want a list, and I can use the toList method to convert it to that. Another thing I want to do is my context. There are other events that you can handle. And one of them is the pre-request handler execute. And this occurs just before ASP.NET starts executing an event handler. So when a page shows up, this will actually be executed. And what we want to do is whenever we access, so begin request begins when the application gets opened up. The pre-request handler execute method will, every time a user requests a page, will execute, and we can use this to actually look at that list and see if the sender's host address is okay. So what I'm going to do is say, I'm going to call my method and I'm just arbitrarily naming them the same as the event handler name. It makes it easier for me to keep track of what's going on. And I'll generate the method stub for that event handler. And so what this is saying is this method will be added onto this event handler, just like the other one. So now what do we want to do with our pre-request handler? Well, I'm going to cast sender as a HTTP application objects so that I can actually get access to the HTTP application properties. And what I need is the request object from the app. So I'll take the app's context and get its request. And so all we're doing with all these casts is basically we get sender. If I had sender here, for example, well, sender's an object. It doesn't have a context. In fact, just like all objects, it just has the four properties that any object has. By casting sender to an HTTP application, now I can get access to the HTTP application objects, and you can see here there's a lot more stuff in here that is useful. And how do I know that sender is an app? Well, just because I know when this method will get called, that what's going to call it is an HTTP application. And so what we're going to do is say if allowed addresses we're going to look at use our allowed addresses, and lists have a contains method that you can pass in a string, and it'll check to see if that string is inside of that list. So if we take the request, and we can get all kinds of things from the request. You can get the user agent, you can get the host address, you can get the host name, the user languages. There's all kinds of things you could look at and respond to and set up in your program. In our case, what we're going to look at is the user host address. And that's just a string. So what will happen is we're going to look at our allowed addresses up here that got filled in the load addresses method. And we're going to see if it contains the user's host address. If it does, then obviously that would be okay. We're actually looking to see if it doesn't contain that, because we put this not operation here. And if it doesn't contain that address, we're just going to throw an HTTP exception. And you have all kinds of exceptions you can throw. We're going to throw the (403), and the message we're going to provide is IP address denied, a nice cryptic message that will send them to a 403 window, and they won't be able to see it. So this way we can control who has access to our website. Like I said, this is not something you might always implement, but you could create your own module this way to do this sort of thing. So next, what we need to do is create a text file with allowed addresses. And we can do that by right-clicking on our project. And we're going to add a new item. And we're just going to add a simple text file. I forgot to name it, so I'm going to name it what we named it in the code. And now we have this allowed addresses.txt file. And we'll just type in some addresses. And then in our web config, we need to add this module. So if we look at web server, we have our handler defined. Just in a way similar to the way we added our handler, we're going to add our module. So modules, and just like we did an add here, we're going to add, provide the name, type, and you notice that when that IntelliSense, there's really only three things: precondition, name, and type. We're only going to use, we only need to use name and type. And we need to provide the namespace and class name of the type that handles the demo, the module, which is right up here. And I tend to like using cutting and pasting to avoid making errors. And we also need to provide the assembly, which is the project name here as well. So this is the namespace of the class that we want to use for our that has the code for our module, and then the assembly which it's in. And then we're going to our handler. We're going to change this process request. And what we want to do with this is, rather than showing just this hello from the customer handler message, we want to show a list of all the modules which are implemented in this application. And the way we can do that is this. I'm going to create a string builder to concatenate in a big giant string which lists all of the modules which are in. And the string builder has an append method. So we're going to use a string builder to build up some HTML code that we're going to display. And if we look at our context object and look at the application instance, it has a modules property, which is a collection of all the modules in the current application. So what we're going to do is we're just going to iterate through that and append it to our string builder to make a string. And so we have an unordered list, and we're going to append the module name between two list item tags. So this will get the modules, and the module, we're going to call its toString method in order to get them. We use the var here because we can probably figure out what this is, but when you don't want to look all that up, you can use var, and the compiler will figure it out for you. Of course, at the end, after we get all of our list items in, then the next thing we need is the closing UL tag. And then we need to display it. So we'll make a variable to hold the request object from the context. And we'll get the browser from that. And so we'll look at this to also look at what the capabilities are of the browser. Make another list. For each through all the browsers, and the keys is an object that contains information about what capabilities the browser has. And so we'll just make a list of all the capabilities that our browser has and also display that. And of course, we also need to append a closing tag for our unordered for the second unordered list as well. So all we've done is just made a big giant string. And we now have this string builder filled up with the HTML that we want to display. And in order to display it, we're going to just add it to the response. So if we take our context and then take the response, we're going to set the content type equal to text/HTML. That way when the browser receives it, it'll render it as HTML. And then we're just going to use write. And notice that the response has write and write file, write substitutions. Basically, the write function is just like writing to a file in many ways. And we're just going to take this response string that we created and use the string builder's toString method to convert all that HTML into just a regular string. And so I'm now going to hit Control F5 and build it and see what we get. And what you get is initially an error because we haven't set a default web page. But if we hit call handler sample, append this text or this extension to your URL, then you get the code that we wrote. And we can see here we have the two things that we wrote. One is the browser is the list of modules that are implemented, and then the browser capabilities. So if we look at here, we have module demo. That's actually the custom module that we wrote, and these are all the things that have been implemented besides. And then down here we have the list of what the browser capabilities are, in this case Chrome, and what abilities it has. So you could look through that list to see if something is, if it's capable of doing something. So that's how we can create a custom module using for .NET. Thank you very much.